Review for exam 2. Let's see the first question. So the second exam and the final exam will be in the same format. So you need to write down, the sentence just to, one way to verify that it's you who's taking the exam. Okay, let's go with the first question. The first question is saying, consider this given function polynomial degree 4, right? Polynomial degree 4. So its first derivative is given polynomial degree 3. You see this is raised by square, this is raised by 1. 2 plus 1, that's raised by 3. So 1 degree down. Second derivative has to be quadratic, right? This is raised by 1, raised by 1. So this is a polynomial degree 2. So original function polynomial degree 4, first derivative polynomial degree 3, second derivative polynomial degree 2. So those are given. So we don't have to take a derivative of this. So those functions are given. So A wants us to identify the x coordinates of the point, well, which point? Which the function has a local maximum. So this is polynomial degree 4, and the leading coefficient is positive. So the graph looks like W. No, this is wrong graph. Looks like this. Yeah, we goes 3 times. We goes 3 times. So we would have 1 maximum, 2 minimum. So how do we know that? First, we know there's a 4 degree 4, even degree. Right? Even degree either goes up or the middle way goes, or goes down. The end behavior. In the middle, wiggles how many times? It depends on degree. What degree is 4, it wiggles 3 times. Degree 6, it wiggles more times, 5 times. Okay, so this is saying identify the local maximum. Local maximum, because it's local, right? So only from certain to certain, because this keeps going, this keeps going. So the absolute maximum will be infinity. So that's why this is called the local maximum. So that's only one. So how do we do that? Remember, the derivative at this point is the same as the slope of its tangent line touching this point. Okay. So which means the derivative of the function at this point x should be 0. So we just do that. We just set this one to be 0. So we have 12 times x plus 1 square, x minus 3, that's 0. You see, this is all multiplication, right? We have 3 things. We have 12 multiplied by this equals 0. So we use 0 property. 12 cannot be 0, so we divide by 12. But then this one can be 0. So x plus 1 may be 0. And x minus 3 could be 0. So we solve this one with square root, right? We square root both sides. Square root 0 still 0. So have x plus 1 equals 0. That means x equals -1. Or here, x equals 3. Okay, so we have 2 critical numbers. So we have 1. Actually, we should have 3 because this is degree 2. So we have 2 of -1. But 2 of the -1 is the same, right? So in the end, we have 2. So we have 2. I have 2 critical numbers. So add these 2. So this graph is misleading. So this graph should be just wiggle twice because those 2 are the same. All right, so how do we know? So now we have 2 critical numbers. So let's draw on the 1. So maybe this is 0, this is -1, this is a 3. So these two critical numbers split the x-axis into 3 intervals, right? From -infinity up to -1, then from -1 up to 3. We don't really need 0 here. Then from 3 up to positive infinity. So two critical numbers split x-axis into 3 intervals. So the first interval, second interval, third interval. So how do we know the function increases or decreases? Remember, if we pick a value, the derivative is positive, so we know the original function in the interval increases. Otherwise, decreases. Or equals 0, it is flat, right? Equals 0 equals flat. So we want to pick a value into those 3. Actually, we only have to do the first one because it's a polynomial, right? Polynomial, the function just wiggles. But to be safe, let's pick 3 values. So pick -2 here. We pick a 0 for in this interval. Maybe you pick a 4 in this interval. So then we just evaluate. So f prime of -2. Remember, we evaluate the derivative function. Okay, so let's just plug in. Let's do here. So if I'm -2, all I have to do is to check if it's negative or positive, right? This is -2. -2 plus 1, -1, -1 squared positive, but -2 minus 3, that's negative, right? So in this interval is less than 0. So that means in this interval, it's downward, right? It's like this. But because at -2, we call multiplicity, we have this 2. So I have 2 values of -1. So the graph just touches x-axis, then turn around. Then we evaluate at 0. At 0, we plug in 0 plus 1 positive, 0 minus 3 negative, so still get negative. So keeps going down, right? It just wiggles, maybe just wiggles, but it keeps going down. Still negative. So at -1, it wiggles, then keeps going down. Then let's check 4. At 4, 4 plus 1 positive, 4 minus 3 positive, everything's positive. So increases. Increases. So this one, so the graph may go. So we don't know the minimum yet, but at 3 is a local maximum. Right? The graph somehow looks somewhere like that. Okay, so now we know. Now we know because from decreasing at 4, increasing at 4, increasing. So then in this interval, it increases. So we know the local maximum. Right? So this is a local minimum. Then at 3 is local maximum. So we after all this work, we see x equals 3 because it only wants x coordinate. Right? So B is find the local minimum. So we already know the local minimum. Actually, in this case, there's no local minimum because at -1, what happened? At -1, it keeps decreasing, right? It keeps decreasing. So no local minimum. Let's see C. C, we also want to find the x value when the function has critical point that's neither local maximum nor local minimum. So we know already x equals -1, right? Because we only solve for 2 critical numbers, -1 and 3. 3 give us local maximum, and -1 is neither. And we call saddle point. Like the saddle, when you ride on a horse, the saddle, right? From one direction, the point looks like a minimum, but from another direction, the point looks like a maximum. So it's called a saddle point. So that's x equals to -1. D, identify x value. Point of inflection. Remember, point of inflection means turn concave up to concave down, or concave down to concave up. And how do we solve it? So inflection point from concave up to concave down, the point is here, or from concave down to concave up. Right? Those points called inflection points. What happened there? That's when the second derivative equals 0. So we set the second derivative to be 0. Then we solve, well, divided by 12 on both sides. So we see x equals to -1 could cause this to be 0. Well, x equals to 5/3 could cause this one to be 0. So get two values, -1 and 5/3. So we solve second derivative equals to 0. Then we solve for x. So x equals to -1 and 5/3. So E, on what interval is the function increasing? Right, now we know from negative infinity up to -1, union -1 up to 3, the function decreases. Right? Before we show it like this. Then 3 to at what interval is the function increasing, right? Then from 3 to past infinity, the function increases. Okay, F. On what intervals is the function decreasing? Right, from negative infinity, this one. On what interval is the graph concave up? Concave up. So this is a concave up. Right, from negative infinity to -1 is concave up. Then from -1 to -3, no, +3, concave down. It wiggles. Right. Then from 3, concave up. 3 to infinity, concave up. On what interval is the graph concave down? All right. Okay, let's see the second one. So given this function, we have one function multiplied by another function. And we want to find its derivative, then evaluate at 1. So let's call this g of x. Let's call this h of x. We see product of two functions, right? And we want to find derivative first. So that's a g prime multiplied by h plus, so the g prime times h plus g times h prime. So let's find g prime. So g prime is 12x squared minus 3. And the h prime is 6 minus 5 over x squared, right? Because derivative of 1 over x is -1 over x squared. So with that, we just do g prime with 12x squared minus 3 multiplied by h, 6x plus 5 over x. Then plus h prime times g. Well, g is 4x cubed minus 3x plus 1. Then multiply by h prime. Well, h prime is 6 minus 5 over x squared. We don't have to simplify it. Now we can evaluate at 1. At 1 of 12 times 1 squared, which is 12. 12 minus 3. 6 times 1, 6. 5 divided by 1, 5. Minus 4 times 1 cubed minus 3 plus 1 times 6 minus 5, right? So 12 minus 3, which is 9, 6 plus 5, 11. Or 5 minus 3, 1, 1 plus 1, 2, times 6 minus 5, which is 1. So the 99 minus 2, this multiplication, equals to 97. Oops. Okay, let's see 3. 3 again, we want to differentiate h prime. We want to differentiate h, right, h prime. So firstly is we want to rewrite this as raised by half. So I have a half, right? Half of whatever this is, 4x squared plus 5, raised by half minus 1, negative half. Then multiply by derivative of this, which is just ax. Then we can simplify a little bit. We have this half times a, that's 4. We like to put a 4x, right? Then this one is raised by negative half, that goes to denominator. Well, raised by half is square root of 4x squared plus 5. Right? So we get 4x divided by square root of 4x squared plus 5. Then we want to evaluate at 1. So 4 times 1 is 4. Square root of 4 times 1 squared is 4 plus 5. Well, 4 plus 5 is 9. Square root of 9 is 3. Well, this one we can rewrite it as, if you want to apply quotient rule, that's fine. Otherwise, we could rewrite as 3x minus 4 raised by negative 1, right? So g prime of x, or let's just do g prime of x first, then we evaluate at 1. We take the derivative of the top, which is 4x plus 3, right? Multiply by the second, multiply by the bottom, which is still 3x minus 4 in the denominator. Then we take the derivative of the second, multiply by the first. So we get it multiplied by the first, we get 2x squared plus 3x minus 7 divided by, what's the derivative of this? Derivative of this is a negative 1 over 3x minus 4 raised by square, because minus 1 minus 1 equals to minus 2. Minus 2 goes to the denominator. Then we have derivative of inside, which is 3. 1 times 3 is 3. So we can multiply the 3 numerator, because this 3 is numerator. Then the denominator will have 3x minus 4 squared. Now we can plug into 1. Plug in 1, we have 4 plus 3, we have 3 minus 4, minus 3 times 2 plus 3 minus 7. Then we'll have 3 minus 4 squared. Simplify, 4 plus 3, 7. 7 divided by negative 1, negative 7. Then minus the numerator will have 2 plus 3, 5. 5 minus 7, negative 2. Negative 2 times negative 3, positive 6. Well, denominator 3 minus 4, negative 1. Negative 1 squared is positive 1. So we get a negative 7 plus 6, we get a negative 1. Well, let's see 5. So given function f of x differentiable, and also we give this 1 point, x value is 1, y value is 1. And this is a derivative function. At 1, the derivative is negative 2. So we want to compute this. So how do we do this? We see, first we see product of two functions, right? We see x times some function squared. So first we take the derivative of x, which is 1, multiply by the second, which is just f of x squared. Then the first one times the derivative of the second one. So how do we take a derivative of f of x raised by square? First, we deal with the 2, exponent 2, 2f of x. Then 2 minus 1 is 1, so f of x raised by 1. Now derivative of f prime of x, right? So this is x times 2 f of x times f prime of x. Then we want to evaluate at 1. So at 1, we have f of 1 squared plus 1 times 2 times f of 1 times f prime of 1. Well, f of 1 is 1, so 1 squared plus 2 times 1 times f prime of 1 is negative 2. So we have 1 minus 4, which is negative 3. Let's see 6. So we want to find the x value for the point of inflection, which means we need to find the first derivative, and also we need to find the second derivative. Then set the second derivative to be 0, right? So let's find the first derivative. So x squared derivative is 2x. Then minus, well, remember 1 over x derivative is negative 1 over x squared. So negative become positive, right? 27 divided by x squared. So first derivative. Well, second derivative of 2x is a 2. Well, what is the derivative of 1 over x squared? We see that's because this is x raised by negative 2, taking derivative, right? So I have negative 2, x raised by negative 3, which is negative 2 over x raised by 3. So I have 2 minus 2 over x raised by 3. Now this is a 0. So this is 0 means we can rewrite as 2 equals to 2 raised by x cubed. Then both sides we can divide by 2. So we get 1 over x cubed. Well, multiply x cubed on both sides. So x cubed equals 1. So which means we cube a root, x equals 1. That's it. So take the first derivative, take the second derivative, we set to be 0, right? Because the point of inflection means the second derivative equals to 0. Let's see 7. So given this curve, so we want to find the equation of tangent line to the graph when x value equals to negative 2. Right? For the equation of the tangent line, so we need to find derivative. Oh, let's use this one. We need to find the y prime or dy dx, right, at negative 2, right? Because of the curve, right, tangent line, we need to find a derivative value at this point, which becomes the slope of the tangent line. But this is not a function, so we need to use explicit differentiation. So which means we take a derivative with x with y simultaneously. Taking derivative with the x term doesn't change of anything, right? So x squared take a derivative still get 2x. But then this xy is a product. So we take a derivative of x, which is 1. 1 times y, we get y. Then we take a derivative of y, we get 1, but multiply by y prime, multiply by x. So get x y prime. Then minus 2y y prime equals to 0. So explicit differentiation, when we take derivative with x, nothing changes, exactly the same as the functions. But when we take derivative with y, we have to attach y prime or dy dx term. So now let's simplify. We have 2. Oh, we see every term has 2 as a factor. We can simplify that. So we just get x minus 2y minus 2x y prime minus, so everything divided by 2, divided by 2, divided by 2, divided by 2, right? Simplify to be y prime. Okay, now those two are like terms, and those two are like terms. So let's move these two to the other side. So we have x minus 2y equals to positive 2x y prime minus y prime. Well, y prime is the common term, and we want to solve for y prime, right? So we factor out y prime. So I have 2x minus y equals to x minus 2y. Right, equation I can switch left and right. Now I divide both sides by this term, 2x minus y. So my y prime equals to x minus 2y divided by 2x minus y. Now I want to evaluate at -2. And y equals 1. So x equals -2 and y equals 1. Just plug in x value, y value. So -2 minus 2, that's -4. -4 minus 1, that's -5. So I have 5 over 4 over 5. If I didn't make a mistake, it's very easy to make mistake. If you spot my mistake, let me know. So that's the slope of the tangent, right? And with this given point, I can do slope point formula. Y minus 1 equals the slope times x minus -2 becomes x plus 2. And that's it. Well, let's see, 8. So Pie Pizza sells 1,000 pizzas per day, rate of change, for $30 per piece. For each $1 discount, the daily sales increases by 50 pieces. So we want to find the price per pizza that maximizes the daily revenue. So we want to find the price per pizza maximize the daily revenue. Well, first let's form the revenue function. The revenue function is the price multiplied by quantity. So we need to find those two things. Price per quantity. So sells 1,000 pizza per day for $30 per piece. Right? So the quantity, original quantity was 1,000. Original price was $30. But now it's saying for each $1 discount, we don't know how many dollars discount. So each $1 discount. So let's see P many discount. Or let's use X actually. I already read down X. X represents the price, all right? And the quantity. So for each, no, we don't want to use X represents the price. We want to X represents the quantity. How many pieces of pizza? All right, so X. So both of this, the price and the quantity, both depends on the discount, right? The discount. For each dollar discount, the daily sales increase by 50 pieces. So we don't know how many dollars discount. Let's still use the actual price, right? So not really the price, but the discount. Let's put this way, the discount. So X representing the discount. Could be $2, could be $3, right? Could be $5, so on and so forth. So for each $1 discount, so the price means, so for how many $1? So that's 30 minus X. Right? Imagine X could be 2, could be 3, could be 4, could be 5, so on and so forth. But for each $1 discount, the sales increases 50 of them. Because each $1 increases 50. For this many, for X many dollars, because that's a discount amount, increases 50 times X. So we have formed this, right? The relative. So this is maximum price. This is maximize the daily revenue, right? So maximize the daily revenue, the price should be 30 minus X, and the quantity, right, should be 1,000 plus 50X. And we need to solve for such X, right? Discount. Okay, let's put this in. So 30 minus X will be our price. Right? X representing the discount. Then multiply by 1,000 plus 50X. So this is a quadratic function, right? And we don't need to simplify it because this is a beautiful form. It's in the factor form. And we could just take a derivative from here, right? How do we find the maximum? This is downward parabola. We need to find this point. So we need to take a derivative. We use the product rule. Product rule is saying take a derivative of the first one, we get -1, multiply by the second one. Plus, take a derivative of the second one, multiply by the first one. Well, the derivative of the second one is 50. Now we can simplify by -1,000 minus 50x plus 30 times 50, 1,500, then minus 50x. Now we want to find this point. The tangent line is horizontal, slope equals 0. So set this one to be 0. -50x, -50x, that's 100x. We'll put to the other side. Then we'll have -1,000 plus 1,500, that's 500. So divided by 100 on both sides, so x equals 50. Oh, hold on. There's something's wrong, right? Something's wrong. Oh, 5 cannot be 50. I was like, how could it be 50? Divided by 100, x equals 5. So the discount should be 5. So then that question is asking, what is the price per pizza, right? So price should be $30 minus 5, because 5 is a discount, $25. So if this pizza store sells each pizza for $25, they will make most of the money. Let's see 9. So a ball is evaporating in the air. So the volume is decreasing at the rate of 6 pi cm cubed. So this gives us the V prime, right? The rate of change per week, right? Centimeters per week. So this is asking how fast is the surface area decreasing when the radius is 2. So R is given, and the surface area. So surface area is given as such. The volume is given as this. So we have a V. Well, we're given V prime. Let's check V prime. So this is in terms of R, right? So we have 4/3 times pi times 3R squared. Because the variable is R. The variable is radius. Pi is a constant. So this 3 cancel this 3. So we get a 4 pi R squared. And then we're given this 6 pi. Oh, hold on a second. Because we want to take derivatives simultaneously with V prime and R prime. So we need to have R prime here. So the rate of change of the radius. So when the volume changes, the radius changes along. So we want to find the rate of change of the radius. So now V prime of 2, we know V prime of 2, right? V prime of 2 equals 6 pi. So which is 6 pi. So 6 pi divided by both sides will divide by 4 pi. So I have 6 divided by 4, which is 3/2. And then, well, R squared, all we know is 2 cm, which is 4 R prime. Let me start from the beginning. Okay, so what do we do with this question? We were given the rate of change of the volume, and we want to find the rate of change of the surface, which is A. But before we do A, we need to find, so because of V and A, right, we cannot make a direct calculation yet. Maybe we could, but we're going to go through R. We're going to go through R. Especially we're going to find the rate of change of the volume because it's given, right? We're going to go through the rate of change of the radius because both in terms of radius, both functions is defined in terms of the radius. Then we find the rate of change of the surface area. All right, so that's our plan. So how do we find the change of the radius? So we do the related rates, right? Remember related rates? We want to take derivative in terms of time. Think about like a dv dt. But we don't want to, get too complicated. So what do? We just use v prime, r prime, a prime. So all of them you can understand as dv dt, the dummy variable time. R prime is dv dr dt. A prime is dA dt, right? Everyone changes in terms of time per week time. But to simplify, we just write down v prime, r prime, a prime, all right? So take a derivative on both sides. So v derivative is v prime. Take a derivative with r cubed, we get a 4 pi times 3r squared divided by 3. And simplify this, we just get a 4 pi r squared. Do not forget r prime, related rates, or dr dt. So v prime we are given 6 pi, and r is also given. R is 2, radius is 2. So we need to solve for r prime. So r prime equals to 6 pi divided by 4 times 4, 16, 16 pi. Pi divided by pi becomes 1. So we divide by 2, get 3/8. Right? So rate of change. Actually, everything is, because it's decreasing, right? Decreasing should be negative, but we don't need to really write down negative. Okay, so 3/8. Now we want to go through the radius change to find area change, the surface change. So we take a derivative with this formula. So dA dt equals to 4 pi times 2r dr dt, or r prime. Now we know r is 2, r prime is 3/8. So this is 16. 4 times 2 times 2, 16. 16 divided by 8 is 2. 2 times 3, 6. Also 6 pi. Okay. That's just a coincidence, or if I did not make any calculation wrong. If I did make calculation wrong, let me know. So, but that's how we find. That's how we find we'll go through the R, the radius, right? So V prime, the rate of change of the volume is given, and through that we find the rate of change of the radius, and through that we find the rate of change of the surface area. So the surface area is decreasing at 6 pi per week. Or 6 pi, this should be cm squared per week, right? Oh, that's it. So that's about it. So the second exam includes related rates. So this probably a little bit difficult. Related rates, especially for number 8. Number 8, you really have to know how to form the function. And then 7, use explicit differentiation. The rest is just take derivatives, right? And use the concepts of first derivative equals 0, give us the maximum or minimum point. Second derivative equals 0, give us inflection points.